Good morning. Good morning. Good morning. How are you this morning? Open up your eyes and let the sun shine in. I've got a sunshine on my shirt. Well, a sunflower, but whatever. A sunshine. Anywho, howdy. So, notes for 7-4 algebra here, writing and graphing exponentials. So, naturally, that first thing that we want to start off with is that generic exponential equation. The essential y equals mx plus b, but of exponentials, not linears. And that is our good old y equals a times b raised to the x power. Keeping in mind that a is our initial value, aka our y-intercept. That's starting point. And b, that base, is our multiplying factor. Telling us, what are we repeatedly multiplying by each time, which makes sense because remember that exponents represent that repeated multiplication. So our base is what we are repeatedly multiplying over and over and over again to get from one input to the next output. Represent repeated multiplication. Okie doke. So let's take a look at the first example, writing and graphing. So we're going to start with some graphing here. Example 1 is asking us to graph the function f of x is equal to 10 times 2 to the x power over that specified interval, and we need to make a table. So naturally, I don't know how to do this like I do y equals mx plus b, so I am going to come right to my calculator because we like to work smarter, not harder. Yes. So 10 times 2 to the x, always double checking what I plug into the calculator because why not? Okay, so it's telling me, it's giving me an interval to graph this over. And right away, I can see that this 3, negative 3, doesn't have the line over it, underneath it. It's morning. So that's going to end me with an open circle. So I'm just going to make my table. I'm going to start x, y, starting at that negative 3 value like we have right there, going all the way to 3, as per what the interval says. And I'm just going to jot that down from my table. It looks like 3 has an y value of 80, 40, 20. And this makes sense because I have a pattern going on here. I'm multiplying by 2 each time, which makes sense because I have a multiplying factor of 2. Kind of crazy. So then 2.5 and 1.25 to finish it off. Okay. And again, this makes sense because each time I'm multiplying by 2 to get to the next one. Not meaning it's still not a constant rate of change. Constant rate of change for linear has to be adding or subtracting by the same amount each time. All right, so taking a look at our graph here, I've got to get all the way up to 80. So 10, 20, 30, 40, 50, 60, 70, 80. If I counted by tens, that would only get me up to there, and that's not using enough of the graph. So I'm going to default to 5s then. And so just like usual, you don't have to number every single one. I'm going up by 5s, so I'm going to count by 5s, but I'm just going to label every other one. So this would be 0, that would be 5, so I'm going to label this one 10, 15, 20, 25, 30. You just got to be careful that you don't mess up the counting. And I'll be the first to admit that some days I am not capable of doing this counting. I'm not really capable of doing it with anything other than like 10s or 5s. And 80 was what I needed to get. So then down here, we've got 0, 1, 2, 3, negative 1, negative 2, negative 3. Okay. So I'm going to transfer this open circle highlight right here to remind myself, open circle. The more I remind myself of that, the less likely I am to forget it. So at negative 3 and 1.25. So negative 3, 1.25 is going to be really, really close to that axis, but not exactly on it. I'm just going to circle that guy right there. Okay, -2 is 2.5, which is just going to be a little bit higher than that 1 point is 5. 0 is right at 10, which makes sense because 10 right there for my y-intercept, 10 right here, my y-intercept. And 1 goes up to 20, and then 40, and then we end it at 80. And when connecting that, just make sure that it's kind of smooth and no arrows, making sure it stops right there at that 80. So again, start and stop point here, so no arrows. That's what that's telling me. We have a start and a stop point. All right, and there's our beautiful little graph. We can label that with f of x. Let's see what it's like. And part B, asking me, is this showing growth or decay? Why? You have a couple of different answers for this, depending on what you're looking at. If you're looking at the equation, you can say that this is going to be growth because the multiplying factor is bigger than 1. So we can say growth because the multiplying factor is greater than 1. Or if we're looking at the table, we can say that it's growth because the outputs are increasing. Or if you're using the graph, you can say that this is growth because the graph is increasing. But make sure, whichever explanation you use, make sure you have the proof to back it up. Like I can use any one of these 3 things because I have both a table and an equation and a graph that I can use to back up my work. You don't want to be talking about the equation having a multiplying factor if you don't have the equation. And last but not least, that y-intercept that it's asking me for, which we have already identified multiple times in this problem, that 0, 10. Coming from that A value right here, or that table value that we talked at, or you can find it right in the graph too.